The concepts covered are factors and multiples, prime and composite numbers, tests for divisibility of numbers, common factors and common multiples, some more divisibility rules, prime factorization, highest common factor, lowest common multiple, some problems on HCF and LCM. Factors. The numbers which exactly divides the given number are called the factors of. We get the number 12 by 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2 and 12 times 1, hence, 1, 2, 3, 4, 6 and 12 are the factors of 12. Note: the factors are always less than or equal to the given number. Multiples. If we say that 4 and 5 are the factors of 20, then 20 is the multiple of 4 and 5 both. Multiples are always more than or equal to the given number. Multiples of 3. Some facts about factors and multiples. 1 is a factor of every number. Every number is the factor of itself. All the factors of any number are the exact divisor of that number. All the factors are less than or equal to the given number. There are limited numbers of factors of any given number. All the multiples of any number are greater than or equal to the given number. There are unlimited multiples of any given numbers. Every number is a multiple of itself. Perfect number. If the sum of all the factors of a number is equal to twice the number, then that number is called a perfect number. Example 1, 28 is a perfect number because all the factors of 28 are 1, 2, 4, 7, 14 and 28, whose sum equals 1 plus 2 plus 4 plus 7 plus 14 plus 28 equals 56 equals 2 times 28. Example 2, 10 is not a perfect number because all the factors of 10 are 1, 2, 5 and 10, whose sum equals 1 plus 2 plus 5 plus 10 equals 18, not equal to 2 times 10. Prime numbers. Prime numbers, the numbers having exactly two factors 1 and the number itself, are called prime numbers. Example, 2, 3, 5, 7, 11, etc. are prime numbers. Composite numbers. All the numbers with more than two factors are called composite numbers, or you can say that the numbers which are not prime numbers are called composite numbers. Example, 4, 6, 8, 10, 12, etc. Note: 1 is neither a prime nor a composite number. Any whole number greater than 1 is either a prime or composite number. See the Eratosthenes method. Eratosthenes was a Greek mathematician, astronomer, and geographer in Egypt in 200 BC. This method is used to find all the prime numbers from 1 to 100. Step 1. First of all, cross 1, as it is neither prime nor composite. Step 2. Now mark 2 and cross all the multiples of 2 except 2. Step 3. Mark 3 and cross all the multiples of 3 except 3. Step 4. 4 is already crossed, so mark 5 and cross all the multiples of 5 except 5. Step 5. Continue this process until all the numbers are crossed. This shows that all the uncrossed numbers are prime numbers and all the crossed numbers are composite numbers except 1. Even and odd numbers. All the multiples of 2 are even numbers. To check whether the number is even or not, we can check the number at 1's place. Example, if the number at 1's place is 0, 2, 4, 6 and 8, then the number is even number. Odd numbers. Any integer that cannot be divided exactly by 2 is an odd number. If the number at 1's place is 1, 3, 5, 7 or 9, then the number is odd number. Note: 2 is the smallest even prime number. All the prime numbers except 2 are odd numbers. Tests for divisibility of numbers. A number is divisible by 10 if it has 0 in its units place. A number is divisible by 5 if it has either 0 or 5 in its units place. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its units place. A number is divisible by 3 if the sum of its digits is a multiple of 3. A number is divisible by 6 if it is divisible by 2 and 3 both. A number with 3 or more digits is divisible by 4 if the number formed by its last 2 digits, units and tens, is divisible by 4. A number with 4 or more digits is divisible by 8 if the number formed by its last 3 digits is divisible by 8. A number is divisible by 9 if the sum of all the digits of the number is divisible by 9. A number is divisible by 11 if the difference between the sum of the digits at odd places, from the right, and the sum of the digits at even places, from the right, of the number is either 0 or divisible by 11. Common factors and common multiples. The factors which are the factors of each of the given numbers are called their common factors. Common factors are finite in number. Example. Factors of 20 are 1, 2, 4, 5, 10 and 20. Factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. Clearly, the factors common to the factors of 20 and 48 are 1, 2, 4. These are called common factors of 20 and 48. Coprime numbers. When two numbers have no common factors other than 1, then the two numbers are called coprime numbers. For example, 8 and 25 are coprime numbers whereas 4 and 10 are not coprime numbers. Common multiples. The multiples which are the multiples of each of the given numbers are called their common multiples. Common multiples are infinite in number. Example. Multiples of 2 are 2, 4, 6, 8, 10, 12. Multiples of 3 are 3, 6, 9, 12, 15, 18. Clearly, the multiples common to the multiples of 2 and 3 are 6, 12. These are called common multiples of 2 and 3. Some more divisibility rules. If a number is divisible by another number, then it is also divisible by each of the factors of that number. Example. 40 is divisible by 20. Factors of 20 are 1, 2, 4, 5, 10 and 20. Clearly, 40 is divisible by each of these factors. If a number is divisible by two coprime numbers, then it is also divisible by their product. Example. 40 is divisible by 4 and 5. 4 and 5 are coprime. Their product is 4 times 5 equals 20. Clearly, 40 is divisible by 20. If two given numbers are divisible by a number, then their sum is also divisible by that number. Example. The numbers 10 and 25 are divisible by number 5. Their sum is 10 plus 25 equals 35. Clearly, 35 is divisible by 5. If two given numbers are divisible by a number, then their difference is also divisible by that number. Example, the numbers 10 and 25 are divisible by number 5. Their difference is 25 minus 10 equals 15. Clearly, 15 is divisible by 5. Prime factorization. Prime factorization is the process of finding all the prime factors of a number. There are two methods to find the prime factors of a number. Prime factorization using a factor tree. Example, prime factors of 70 in two ways. The prime factors of 70 are 2, 5 and 7 in both the cases. 2. Repeated division method. Example, prime factorization of 64 and 80. The prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. The prime factorization of 80 is 2 times 2 times 2 times 2 times 5. Highest common factor. The highest common factor, HCF, of two or more given numbers is the greatest of their common factors. Its other name is greatest common divisor. Example, HCF of 60 and 72. First, we have to find the prime factorization of 60 and 72. Then encircle the common factors as shown below. LCF of 60 and 72 is 2 times 2 times 3 equals 12. Lowest common multiple, LCM. The lowest common multiple of two or more given number is the smallest of their common multiples. The methods to find LCM are as follows. 1. Prime factorization method. For finding the LCM, we have to find the prime factorization of all the given numbers and then multiply all the prime factors which have occurred a maximum number of times. Example, LCM of 60 and 72. Step 1. Find the prime factorization of 60 and 72. Then encircle the common factors. Step 2. Count the common factors one time and multiply them with the other remaining factors. Example, 2 times 2 times 2 times 3 times 3 times 5 equals 360. The LCM of 60 and 72 360. 2. Repeated division method. This method is used to find the LCM of so many numbers. Example, the LCM of 105, 216 and 314. Step 1. Use the repeated division method on all the numbers together and divide until we get 1 in the last row as shown below. Step 2. Count the factors one time and multiply them. Example, 2 times 2 times 2 times 3 times 3 times 3 times 5 times 7 times 157 equals 1,186,920. LCM of 105, 216 and 314 is 1,186,920.